Uranus, the cosmic punch that tilted our sideways planet. Welcome to Cosmic Enigma, where we unravel the universe's most mind-bending mysteries. Today, we're tackling one of the solar system's greatest head-scratchers, Uranus. Imagine the solar system as an elaborate cosmic dance floor, where most planets gracefully orbit the sun, spinning upright with elegant precision. However, one celestial body stands out, performing a perpetual side shuffle. This is Uranus, the ultimate rebel of our planetary neighborhood. It appears to be literally rolling on its side, as if an unseen force tipped it over, and it simply chose to remain in that unusual orientation. The fundamental question arises: what cosmic event could have profoundly impacted Uranus to induce such a distinctive spin? This peculiar tilt represents one of the solar system's most enduring unsolved mysteries. This exploration delves into the leading scientific theories that attempt to explain this wild phenomenon. We'll explore why this planetary oddball is so unique and what it means for its bizarre environment. Before diving into the theories behind its unusual orientation, let's get acquainted with this mysterious blue-green celestial body. Uranus is the seventh planet from the Sun and holds the distinction of being the third largest planet in our solar system, with a diameter approximately 4 times that of Earth. Its most remarkable attribute, however, is its axial tilt. While Earth maintains a comfortable axial tilt of 23.5 degrees, responsible for our planet's varied and predictable seasons, Uranus presents a stark contrast with an astonishing tilt of nearly 98 degrees. This extreme inclination means the planet is virtually lying down as it orbits the Sun, a visual anomaly that distinguishes it from all other planets. This profound tilt has far-reaching implications for the planet's climate, atmospheric dynamics, and overall environment. It's also important to clarify that Uranus, along with Neptune, is classified as an ice giant rather than a gas giant. Unlike Jupiter and Saturn, which are predominantly hydrogen and helium, Uranus possesses a significant proportion of ices, water, methane, and ammonia in its interior, surrounding a molten rocky core. This classification reflects a more precise understanding of its molecular composition and contributes to its powerful magnetic field and irregular seasonal patterns. The foremost scientific explanation for Uranus's dramatic axial tilt is known as the giant impact hypothesis. This theory posits a cataclysmic event occurring billions of years ago during the tumultuous early stages of our solar system's formation. In this chaotic era, when planetary bodies were still coalescing and massive collisions were common, a colossal object, estimated to be the size of Mars or even larger, potentially a protoplanet, collided with a nascent Uranus. This was no minor impact. It was a devastating grazing blow delivered with immense force, sufficient to fundamentally alter Uranus's rotational axis and effectively knock the planet onto its side. The theory suggests that the impact was so energetic that it reset the angular momentum of the entire system, or that the satellites and rings subsequently reformed around this newly established axis. This provides a cohesive explanation for why not only Uranus, but also its moons and rings share this peculiar tilted orientation. Scientists have rigorously tested this hypothesis through sophisticated computer simulations, which consistently indicate that a grazing impact with an object of the proposed scale could indeed account for Uranus's extreme axial tilt. Furthermore, this theory offers a compelling explanation for another long-standing Uranian enigma: its unusually low internal heat radiation. Unlike Jupiter and Saturn, which emit more than twice the heat they receive from the Sun, Uranus radiates barely any internal heat. The colossal impact, according to this hypothesis, might have literally expelled much of Uranus's primordial heat, leaving it with its current, cooler internal state. While the giant impact hypothesis remains widely accepted, another compelling and more recent theory offers an alternative explanation for Uranus's extreme tilt. Proposed in 2018, this hypothesis suggests that Uranus may have once harbored a massive moon, a veritable Moon-ster, that engaged in a prolonged and intricate gravitational interaction with its parent planet. This alternative perspective posits that, over hundreds of millions of years, this enormous satellite gradually destabilized Uranus's axial tilt. The mechanism involved the Moon's orbit slowly sinking into resonance with the planet's spin, allowing its immense gravitational pull to progressively increase Uranus's inclination, potentially by as much as 80 degrees. The culmination of this gravitational dance, according to the theory, would have been an inevitable colossal collision. As the Moon's orbit continued to shrink and condense due to tidal forces, it would have eventually crashed directly into Uranus. This final impact would then have locked Uranus's axis into its current exaggerated tilt. This theory introduces a fascinating element of scientific debate, demonstrating that the mystery of Uranus's tilt is not entirely settled, and that the scientific process involves continuous investigation and refinement of understanding. Living on a planet that effectively rolls around its star leads to some of the most extraordinary and dramatic seasonal cycles in our solar system. Uranus's extreme axial tilt results in unparalleled seasonal variations. For significant periods lasting up to 42 Earth years, which constitutes half of Uranus's lengthy 84-year orbital period, one pole experiences continuous sunlight, while the opposing pole is enveloped in absolute darkness. Following this prolonged period, the poles reverse their exposure to the sun. This leads to extreme and prolonged heating and cooling cycles, which in turn drive highly unusual atmospheric circulation patterns and generate powerful winds. The potential for truly unique and complex weather systems on Uranus, which scientists are still striving to fully comprehend, is a direct consequence of this extreme orientation. Beyond its atmospheric effects, the tilt also profoundly influences Uranus's magnetic field. Unlike Earth's relatively aligned magnetic field, Uranus's magnetic field is substantially tipped relative to its rotation axis and is significantly offset from the planet's center. This creates a twisted magnetic tail that extends millions of miles into space, further adding to the planet's unique and perplexing characteristics. Beyond its peculiar axial tilt, Uranus is replete with other fascinating and unique attributes. As mentioned, it is accurately classified as an ice giant, distinguishing it from the gas giants, Jupiter and Saturn. Its internal structure comprises a molten rocky core enveloped by a thick, dense layer of water, methane, and ammonia ices. The planet's striking blue-green coloration, a visual hallmark, is attributed to the presence of methane in its atmosphere, which efficiently absorbs red wavelengths of sunlight and reflects the blue light back into space. Uranus boasts a retinue of 28 known moons. A particularly charming aspect of these satellites is their nomenclature. Most are famously named after characters from the literary works of William Shakespeare and Alexander Pope, including well-known figures such as Titania, Oberon, Miranda, and Ariel. This unique naming convention, coupled with Uranus being the only planet named after a Greek god, Ouranos, the god of the heavens, rather than a Roman deity, reinforces the planet's overall distinctiveness and rebellious persona within the solar system. Furthermore, Uranus possesses a system of rings, consisting of two faint sets that collectively comprise 13 individual rings. While these rings are not as visually prominent or extensive as Saturn's, they are composed primarily of small, dark, icy, and dusty particles. Intriguingly, during the Voyager 2 flyby in 1986, evidence was found suggesting the presence of boiling oceans located approximately 500 miles beneath Uranus's outer atmosphere. This counterintuitive discovery, given Uranus's status as one of the coldest planets, adds another layer of wonder and paradox to this already captivating ice giant. Despite the compelling nature of the giant impact hypothesis and the intriguing Moon-ster theory, the definitive explanation for what precisely impacted Uranus and caused its extreme tilt remains one of the most significant unsolved mysteries in our cosmic neighborhood. Our current understanding of Uranus is largely derived from a single close encounter. NASA's Voyager 2 spacecraft, which performed the flyby in January 1986, providing humanity with its first and only close-up images and data of the planet and some of its moons. However, the quest for knowledge continues. Various space agencies, including NASA, have proposed and are actively developing concepts for future missions specifically designed to explore Uranus. These upcoming endeavors hold immense promise, as they are expected to provide unprecedented new data and deeper insights into the planet's atmosphere, magnetic field, internal structure, and the dynamics that govern its peculiar orientation. Such missions could finally unravel the long-standing riddle of this sideways ice giant, revealing what other secrets Uranus might be holding within its enigmatic blue-green depths. The ongoing nature of this scientific inquiry, with the anticipation of future discoveries, underscores that the story of Uranus is still unfolding, maintaining the topic's relevance and inviting continued engagement with the evolving understanding of our solar system. In summary, Uranus, our distinctly sideways planet, most likely acquired its extreme axial tilt through one of two primary scenarios: either a massive, cataclysmic collision during the chaotic formation period of the early solar system, or a prolonged and dramatic gravitational interaction with a colossal moon that ultimately culminated in a destructive impact. This profound tilt is the direct cause of Uranus experiencing the most extreme and prolonged seasonal cycles in the entire solar system, cementing its status as a truly unique ice giant. The universe is an endless source of astonishing narratives, and the story of Uranus is undoubtedly one of the most extraordinary and captivating. If this cosmic exploration has ignited your curiosity, please consider expressing your appreciation by engaging with this video. A simple like helps to support the creation of more content. Subscribe to the channel for a continuous stream of mind-blowing astronomy discussions, and join the conversation by sharing your thoughts in the comments section. What other cosmic mysteries would you like us to unravel next? Clear skies.